This is the most common oscillator diagram. The first thing you'll notice is that it is somewhat symmetrical. Does that mean that the left half and the right half are both doing the same thing? Yes, but not at the same time. In fact, one half turns the LED on, and the other half turns it off. Let's look at the result first. The LED lighted for a while then turned off, the lighted again. Understanding this in detail is tricky, because the voltages are constantly fluctuating, and more than one thing is happening at any given moment. A transistor has base, emitter and collector. The base is the gate controller device. The main key here is the transistor. In the original schematic, notice that R1 and R2 have much lower values than capitalized R1 and R2. This will allow the left side of left capacitor to charge quickly, almost to the full value of the supply voltage. Here's the two-state we have in this circuit. The first one is the current flows through the transistor and LED turns on. The second is the current doesn't flows through the transistor and LED stays off when you first power it up. Why shouldn't both of the transistors be on, or both of them off? In a perfect world, where two transistors or two resistors can be absolutely identical, the circuit would initialize itself symmetrically. But in reality, there's always a tiny manufacturing difference among resistors and capacitors, causing one transistor to start conducting before the other. As soon as that happens, the circuit is out of balance, and it starts to oscillate. Because of manufacturing difference, one transistor turns on, let's say left transistor. This causes its collector voltage to decrease, the left side of left capacitor voltage decrease. Instantaneously due to the electricity pulse caused by charging of right capacitor, the voltage on left capacitor would decrease the same amount like battery. The base of left transistor get lots of electricity, so the left side of left capacitor use lots of electricity. And the right side of left capacitor decreased the same amount of voltage and became negative due to bigger resistance on right side compared to left side. The same decrease in collector voltage of left transistor shows up as a decrease in base voltage of right transistor, because right transistor is connecting with the right side of left capacitor. This turns off right transistor. The collector of right transistor stays off, so left transistor stays on. However, left capacitor is still charging in different rate left and right side due to different resistor. Eventually the right side of left capacitor charges up even the voltage is so small. This will eventually get to a point where it turns on right transistor and allow a sudden electricity pulse to pass through. That causes right transistor to turn on and use electricity on the right side of right capacitor, turns off left transistor. Because if left transistor is off, more electricity will remain in left capacitor, and will let right transistor get more electricity on its base, etc. The net effect is that left transistor and right transistor flip states. The same thing happens regardless of the sizes of the capacitors over a wide range. However, the time to flip to the other state depends on how long it takes to charge up the base side of a cap.